Okay, starting page 2, says using the graph to the right, what is the y-intercept and what does it mean in this situation? So the y-intercept is right there because this is my y-axis and the x-axis. So it ends up being about, let's see, where's the y-intercept? So it's not quite 100, so I'm going to say it's 75. So the y-intercept is 0, 75. And what this means is that it says the cost of Dion's graduation picnic. So here's a number of attendees, here's the cost. So at the very beginning, there was a flat fee or a cost of $75. So an initial fee or a flat fee. If 100 people attend the graduation picnic, what is the approximate cost? So there's my 100. I'm going to follow it all the way up to here, which is not quite 1,000. So I'm going to guesstimate that it's about $960. $960, $970, somewhere around there. And then how much does it cost? How much does it cost for every 10 attendees? So when it says cost for every, that means you're looking for your slope. Okay? So we're trying to figure out our slope. So I'm just going to kind of look and eyeball where I'm at here. So it looks like if we kind of, if we were to blow this up a little bit, we can kind of guesstimate that if we said this was 90, this looks like it's about, 190. So maybe that's close to 100 per 10 people. So $100 per 10 people or $90 per 10 people. So we're looking at slope. So again, 90, so about 90 to $100 for every 10 people. So remember, slope is rise over run. Number 8, we are looking at the graph dealing with water in the tank, determining which statement is true. So the water in the tank is empty at 5 p.m. Well, here's the depth of my water. So this is when it's empty. So at 5 p.m., nope, we're not at 0, so that's not correct. The water in the tank is decreasing at a rate of 2 feet per hour. So if we look at per hour, so from noon to 1, looks like we're going down there to 1 o'clock, so there's 1 hour, so we're looking at this. And this is about 6 inches per hour. 6 inches per hour. So it says the tank is decreasing at a rate of 2 feet per hour, and that is not true. There was no water in the tank at noon. Nope, we started off with 5 feet of water at noon, so that's not it. It says the water in the tank is decreasing at a rate of 1 foot every 2 hours. Well, if it's 6 inches every hour, then it's going to be 12 inches every 2 hours. So if I double this and double this, so yes, this would work. Moira is working at a local car wash and is trying to save money. So she currently has $820 in her account. She is earning $140 per week and putting it all into her savings account. So how much money will she have saved after working 8 weeks? So we have, so she's aiming for that. She has this much in her account, so she already has that much. So 820 plus she has 140 per week. It's 140 per each week, so I needed to find the variable as W being the number of weeks. Equals, and we're going to say a capital S for savings account. Equals money in savings. So then if we are looking for 8 weeks, we are going to substitute the W with the 8. Figure out how much money she has. So 820 plus 140 times the 8 gives you $1,940. How many weeks will she need to work to save enough money to buy the car? So remember, this is her goal of $2,500. So that's what we need to have in savings, or she needs to have in savings. So we're working this one backwards. So 820 plus 14W equals, we need $2,500 in savings. So we're going to go ahead and subtract 820 from both sides. So 140W equals whatever 2,500 minus 820 is, which is 1,680. Divide both sides by 140 to determine the number of weeks. So she would need 12 weeks to save that money. And then write an equation to represent the situation, define the variables. I've already done that. I did that up here. So 820 plus 140W equals capital S, and I said W equals number of weeks, and capital S is the money in savings. Okay, so that concluded page 2.